Right. So I'm going to be talking today about balancing cognition with collaboration, or individual team flow with cross-team collaboration. So if you've got multiple teams all working on something that has to come together, how do you do that effectively? So first of all, a little bit about my journey, about what got me here. So I've worked with quite a lot of different team organizations, so teams made up of maybe 2 or 3 teams collaborating on different things, up to more recently in robotics. I've been working with 20 teams all collaborating on one product. And how does that all come together effectively? In terms of domains and technology, again, there's been quite a broad range. So teams have been working on things from things like low-level C for real-time control and safety systems, through mobile app development to back-end cloud services, which are elastically scalable. So quite a varied technology stack. Also quite different release strategies as well. So we've got teams that have been releasing into production multiple times a day, through to teams that are releasing a new feature of our product to our customers maybe once every 10 weeks. So there's quite a broad range as well in terms of how frequently the teams have been releasing. But actually, interestingly, regardless of the technology the team was using, regardless of the frequency with which they were releasing, there were a set of common challenges that I was seeing, but it became particularly apparent when working in the most recent team building a robotic vacuum cleaner. So the challenge we had was accelerating whilst innovating. Is how do we go faster whilst also trying to do something new at the same time? So in terms of where we were starting, so our team was growing over a period of about 2 years. Probably the team got about twice as big. So that was bringing some challenges. We also had new problems to solve. What you can see on the right here is our most recent robot vacuum, but pretty much almost all of the hardware was completely new. So we had robot vacuum cleaners in the market already, so we were trying to reuse as much of the software that we've written as possible, but actually the entire platform that it was running on had been rebuilt from the ground up. So we had, as I said, we had a code base that we needed to evolve, plus we also had quite a lot of code that we were going to write new for the first time because the hardware was completely different. Also, we had lots of dependencies. So all of these teams, all working on different parts of the software in this robot vacuum, all have to work together ultimately so that one thing can move around your home autonomously and clean everywhere, which actually leads to lots of dependencies between the different teams. And then as we were growing, as we had new problems to solve, we also found that we had new gaps in ownership. As we've been growing, actually we've got an area now which we haven't necessarily got an owner for. And so how do we plug that gap? So in terms of who we are, this is our amazing team. So we're split between 4 countries and 2 time zones. And this is us. So in terms of the balance that we were trying to get right, so what we were trying to do was look at how can we organize ourselves around and our team boundaries to reduce dependencies between our teams and also reduce the cognitive load on our teams, whilst at the same time was like, well, actually, how can we effectively innovate with the complexity brought about through the dependencies that we've already got? Because there's no getting away from some of those dependencies when everything has to run together. And it was like, how do we get the balance right between these two? So the first place we turned was Team Topologies, a wonderful book by Matthew Skelton and Manuel Pace. And in terms of what led us there was we were looking at how can we reduce the cognitive load on our teams, because actually it just wasn't possible. The software in our robot was getting so complicated and in some places complex. It just wasn't possible for every single team to know everything anymore. I'm like, okay, well, how can we split this problem down into a smaller set of problems which individual teams can own? Because it's just not possible for everybody to hold it all in their heads anymore. So also then looking at team interactions, because as we were finding lots of teams needed to collaborate together in order to actually get a change, a new capability of our robot out to our customers, with all of those interactions, it was impacting the speed with which we could actually get the changes out. And then lastly, we were finding, and I think probably everybody finds this, based on the responsibilities our individual teams had got, it was impacting how our architecture was evolving. So we're like, okay, we need to be very conscious about how we're structuring our teams, what our team responsibilities are, because it's ultimately going to impact the architecture of the product that we're building. So the core tenets of team topologies, which we took away, and there are lots of wonderful things in the book, but these were some of the key takeaways for us. The first one was stable delivery teams as a means of delivery. So actually setting up teams with a group of people who will be sort of constantly working together. So, and then bringing work to the team rather than having a set of defined problems and then bringing different people in all the time. So that was one of the first takeaways. The next one then was, how do you organize those teams so that actually it's easy for teams to focus on one area? There's not a lot of dependencies, and they're actually able to work effectively. Then next one, evolving team interactions for innovation and delivery. And then lastly, looking at what are the things about the problem that you're trying to solve, maybe about how our business is structured, which gives us a clue as to what would be a good place to have a separation from one team to another team. So team topologies then broadly talks about four different types of teams. So we have stream-aligned teams, which their primary responsibility is to be able to release value directly to customers. So they will have responsibility for certain areas of the product, and they can make changes to those and get those out to production without being dependent on a lot of other people. So we have enabling teams who are there basically to help other teams, to help all the other teams be successful. Complicated subsystem teams, of which we actually had quite a lot in the robot. And then lastly, platform teams that are building out the common tooling, the common capabilities to allow all the other teams to more easily be able to develop. So in terms of how we introduce the ideas, so we had a book club, which one of the books that we took to the book club was Team Topologies, and we were getting together once every couple of weeks. We were reading a chapter, going away, talking about it, maybe trying some of the things in there, coming back together and then talking about how it had gone, how we found it. One of the really lovely things that came out from that book club was the idea of, well, why don't we try actually mapping out how all of our teams are interacting with each other. So look at which teams are we talking to, how frequently are we talking to those teams. And that was really interesting, give us an idea of, like, have we got the structure right? Which teams are talking to each other a lot, and which ones maybe aren't talking to each other a lot, and maybe that might be a good place to define an area of responsibility. So over the period of about, I would say, probably about 18 months-ish, we tried hard at making it sort of clear what teams would own. We looked at what sort of type of team they would be. And actually, things went quite well in doing that. We found that as we made it clearer, the responsibilities for the team, and we sort of talked about and reasoned about, well, what sort of team is this? What is the area they're responsible for? We found actually defining which team or teams will be a platform team worked really quite well for us. That was quite straightforward. Again, complicated subsystem teams, that turned out to be quite straightforward for us in terms of understanding what are those main areas of technology that need to come together for the whole product to work. And again, enabling teams or team. So we went for a single enabling team. But then when it came to stream-aligned teams, that was where we were finding we had some challenges. It wasn't quite working the way we hoped it would, but that aside, actually, when we looked at each individual team and we talked to each team about how things were going, like, actually, no, things have improved. Actually, we've got less dependencies now, and teams are able to make headway without lots and lots of dependencies, lots of talking. So we're like, oh, that's good. Happy days. But that's not the end of my talk, because then what we found is like, but hang on a minute, each of our individual teams is actually able to move faster now, but when we look at how quickly we're able to get a new capability of our robot out to our customers, that hadn't moved faster at all. We were going pretty much the same speed we were going before. We're like, well, what's going on here? What have we got wrong? So when we had a look at what were the sort of things that were going wrong, one of the first things we found was that because actually teams didn't have to necessarily talk to each other a lot now, because we'd sort of worked quite hard to try and reduce the dependencies between the teams, teams weren't necessarily talking as much as they had been, and that meant that actually, quite often, we could have one team and another team doing a very, very similar thing, and they didn't know because they weren't talking together. The next thing we found, and this was a problem that I think was probably more unique in robotics than probably some other domains, because it's not a problem that I'd seen so much when working in other areas of Dyson or other companies, was that we suffered quite a bit from unexpected breakages or breakages from unexpected dependencies. And I'll touch on that a bit more and explain why that was a problem in a bit. So the next thing we found was that, again, because we've sort of done quite a good job of sort of trying to carve out what teams would be responsible for, when it came to trying to make a cross-cutting change through a number of teams, actually that was much harder than it had been before, because there were a lot of teams that weren't necessarily talking as much as they had been together, and therefore trying to get everybody aligned on how we were going to make that cross-cutting change actually became harder. And then the other thing we found was that, again, because teams weren't talking so much, and because teams weren't necessarily so aware of everything that was going on, all the things that were going on in the other teams, we were finding that, and because we tried quite hard to make it so that it was clear to a team what their responsibility was, what they were accountable for. When there was a problem that came up, they would try quite hard to try and solve it, because we're accountable for this part of the product working well. But what that did lead to is quite often that we'd find that we'd actually fix the problem in the wrong place. So we'd fix the problem in the place where the team had responsibility for, but that may not have been the best place to solve it overall. So those were the problems. I'm like, okay, well, team topologies, or the things that we took away from team topologies hadn't necessarily helped us with these things. So we're like, okay, well, what can we do about this? So what we were looking at was like, okay, so how can we improve things at a team level, but also make sure that things are improving overall at the same time? So what we were looking at was how can we balance the narrowing the scope of what teams need to worry about with keeping that situational awareness of how does the bit that I'm doing fit into the bigger picture. So the next place we turned, almost by accident, was Team of Teams by General Stanley McChrystal. And the reason that we turned to this was we were looking at, okay, well, how can we best share knowledge between our teams? We've got lots of teams that needs to be collaborating together, but that's not necessarily working as well as it could be. When you've got a complex problem, and certainly having a robot that you can put into anybody's home, into effectively, as far as the robot is concerned, an infinite number of environments, and it just needs to work, that's quite a complex problem. So actually solving that complex problem needs quite a broad knowledge. Then how do we get to a place where our teams can best work in the open? So whilst they've got a responsibility for a certain area, it's still clear to other teams what's going on. And then lastly was like, okay, well, how can we reduce the impact of the interfaces between our teams being inertia to how quickly we're able to make changes, how quickly we're able to innovate. So some of the core tenets of Team of Teams, the things that we're like, oh, actually, this might well help us, because this certainly describes the things that we're trying to improve, was a common purpose. So how can we make it clear to all of the teams what it is that we're trying to achieve? And actually, not only did this impact how individual teams were working, but it actually changed quite a lot in terms of how we presented what we wanted to try and achieve to all the teams collectively as well, so that together everybody was understanding, well, what is this common purpose over the next 10 weeks, say? What is it that we want to try and achieve? Then shared consciousness, so how do we get that idea that everybody has an idea about what's going on, particularly at the places where it interfaces to them? but then we want to make sure that we retain that empowered execution. So we still want each team to feel that they are absolutely empowered to be able to execute independently, and but do that in such a way that there's that level of trust between them and the other teams in terms of everybody understanding how their bit fits in, and that they can trust that if it's going wrong, actually the best place to fix it is somewhere else, and I will trust that the other team is going to fix that. So what we were trying to avoid was a situation of like, okay, well, we've got really clear interfaces now, so yeah, basically just talk to the API because we're too busy, our team's too busy focusing on the things that we're doing. So we wanted that clear interface, but we also wanted our teams to be regularly talking as well. And it was like, how do we get both of those? So in terms of what we were aiming for and what we wanted to try and avoid, we were aiming for autonomy, but without siloed thinking. We were aiming for a reduced cognitive load in each of our teams, but without that reduced situational awareness of what was going on. And then lastly, we were looking for a clear responsibility, but without the loss of collective ownership. So what did we do? What helped us in that area? So the first thing that we did was we kept the individual team responsibility, but we actually possibly, maybe over-indexed, I don't know, in terms of how we were sharing between the teams. So at the end of every couple of weeks, when our teams had been working on new capabilities, they had been getting together and sharing what they'd been doing with some of the key stakeholders that cared about the output of that particular team. But what we hadn't necessarily been doing is making sure that we were sharing between all the other teams as well at the same time. So what the model that we moved to was that every couple of weeks we would get together and every team would demo what they'd been doing, and there would be like a time slot almost of when that would happen. And we said to teams, well, look, we're going to do this and we're going to go through all of it. If you want to be there and understand what's going on in other teams, then that's great, come along, but don't feel that you need to. Interesting, what we found is when we did it, most people tended to turn up to that to get an idea about what was going on in the other teams. The other thing that we also ended up doing was daily, one representative from each team we would get a group of people together with one representative from each team and just talk about what are the big problems that we've got at the moment, what's not working, is there something somebody else could help us with, are there any significant things that we're changing which might impact somebody else? And again, we said, it would be great if you want to be here. It would be helpful for you to at least come and share the things that you're changing so that another team knows, but don't feel that you have to stay for the whole session once you've done that. But again, we tended to find that quite often people would turn up every day just to give that sharing about what was going on, and particularly when there were problems, and sharing about, so is there anybody else who can help? The other thing that we looked at, and this was because quite often the problems that we were solving were changing, so we hadn't always got, whilst we'd got this nice clear area of responsibility between our teams, the problems that we needed to solve didn't always neatly fit into all of those teams. And we're like, oh, this is a bit awkward because actually we want to be focusing on the most important thing, but that doesn't naturally split easily between all of our teams. So one of the things that we did was have primary and secondary responsibilities. So a team had a primary responsibility for one particular area, but a secondary responsibility for another area, so that when the work and the problems were changing, we were able to flex a bit. And also what we tried to do was, if possible, we tried to have somebody in each time zone that had either a primary or secondary responsibility for all the different parts of our system. So that if somebody was working on something that was interacting with another service that another team was responsible for, at least there was somebody in the same time zone they could reach out to try and understand it. And because they had a secondary responsibility, they'd been doing a bit of work in that area, it was easier for them to help out. Another thing, and again, this was, I think, certainly it was a problem that we had. Whether it's a problem that's unique to robotics, as to whether it's a problem that was unique to our implementation of robotics, I don't know. But we had an awful lot of complicated subsystems in our robot for doing very, very specific technical things. What that meant is that actually to deliver any new feature or capability across our product, it quite often spanned quite a few teams. And I'll get onto that in a minute and to give you a feel for what that looks like. But what that meant was that it was quite hard to have a lot of stream-aligned teams that were responsible for a feature end-to-end, because actually a lot of our features ran through quite a few different teams. So what we did is we said, okay, well, we're not going to be able to get to that where we've got lots of stream-aligned teams, but what we can do is have teams that have a responsibility for a particular capability of our product. They're responsible for monitoring those metrics in production, understanding how it's working, and wherever possible, we tried to align the end-to-end feature of the product with a complicated subsystem that had quite a bit of impact on that feature. So the team would be naturally caring about it anyway. But that was quite helpful in terms of the team they still had to monitor things in production. They had to understand exactly how that feature was working, which was helpful from us because it meant that we didn't then have gaps where there were features of our product that nobody owned. The last one then, so I've got a shorthand here where it says triaging system-wide bugs. In our robot, it's quite common that you can put a robot into a home and ask it to do something, and there'll be something about what it does that is not quite desirable. It's not working exactly the way that you want. Now, quite often those would be raised as bugs. Quite often when we looked at them, we're like, well, no, it's doing exactly as it's designed to do, but what it's designed to do isn't working well in that application. So quite often where it says bugs, it was like triaging system-wide problem reports, where people, it's like the system's not doing, the robot's not cleaning in the way that I want it to. Why is that? And so what we did is we shared the love of triaging those problems, and purposefully actually, between all of our teams, because in trying to understand where is the most likely going wrong meant that people had to delve into a few other areas, and it gave, not only did it mean that we were able to triage quite a number of those things, because when you've got lots of robots in people's homes, you're getting quite a lot of reports, particularly when you're making changes quickly of things that aren't necessarily working as required. There's quite a lot to get through, but it had the nice side effect that actually it was giving teams a wider appreciation of how the whole system was working at any one particular time. And again, there were some subtleties there which we can get into later, maybe if anybody's got any questions on that. So in terms of then reducing coupling whilst collaborating, what were we trying to do? So we were trying to organize our team boundaries align with our business and how we wanted the architecture of our product to evolve to support it, but balancing that with how do our teams continue to collaborate closely across those boundaries to get there. So just by way of examples, I was talking earlier about dependencies and that actually quite a lot of the features that we would build in the robot cut across quite a few of the teams. So just to give you an example of that, on the front of the robot, we've got some time-of-flight distance sensors. So they're ooh, maybe I can do this. Yeah, there we go. So there's a couple of distance sensors, one pointing out here and one pointing out here. The idea of those distance sensors is so the robot can actually detect something before it bumps into it and then avoid it. So those distance sensors are quite sensitive. So the distance sensors have got quite a large field of view, which you can tune. So what we wanted to be able to do was make sure that, hopefully, we always wanted to see objects that we didn't want to bump into. But the trouble was, there were things like quite deep pile rugs, which look quite a lot like an object, but actually you do want to be able to get onto those rugs to clean them. So we did quite a bit of work in terms of tuning what's the right level that we should be getting from these distance sensors to consider to be an object. And then maybe we'd have a problem and think, actually, we haven't got that quite right. And that was quite low level. So that was like the real-time control systems. We were tuning, what's the field of view, exactly what should we consider to be an object or not an object. But when we made changes to that, it had quite a large impact across the whole robot, because if all of a sudden you tuned it so that actually, well, okay, now we're not detecting a rug, as an object anymore so that we can actually get onto it. But that then meant that maybe we weren't detecting some chair legs as objects because of the way that we tuned it. And that meant now all of a sudden, so we'd made a change to allow the robot to easily be able to climb onto something, but that was now meaning that the robot was maybe not seeing chair legs, which meant that possibly it was getting into areas that it couldn't get into before, which then had an impact on how we were mapping the environment. It had an impact on how we were path planning to move around the environment. So a simple feature of adjusting the robot's behavior so that it didn't get stuck or it navigated onto rugs could actually have quite a wide impact across quite a few teams. That wasn't necessarily, that coupling wasn't necessarily at a code level. That was like, because all of these things are all working together in one robot, there were impacts of making those decisions. Quite a lot of that came from actually a lot of the optimization that we were doing, that I think often you're doing in robotics, is like performance. There's no right or wrong answer. You're doing a lot of performance testing. You're putting it into a lot of environments and getting the right balance, like what is the best trade-off between all these different things that I can tune. So in terms of reducing coupling whilst collaborating, so we were aiming for increased team flow, but without ignoring the coupling that was there. So whilst we didn't want it, it wasn't going away, so we had to deal with it. So we were looking at reducing dependencies between the teams, but without losing coherence. So we still wanted the whole system to work together coherently. And we wanted team boundaries, but without it being a resistance to evolution and actually changing the way that our software was working. So what helped us with this? So the first thing was basically not ignoring the coupling that was there. I mean, the fact we didn't want it meant that we shouldn't ignore it. And therefore, we were looking at, well, given that actually when we make a change here, it can impact in these other areas, is making sure that we're bringing those teams that could be impacted together when we're making the change so that it's clear, at least people are aware, so that when something, because it may have no effect. We can make a change and it may have no effect on the other teams, or we can make a change and it has a significant impact. But at least if people are aware that a change is going on, they know to look out for it. So the next thing that we did was, so this was more to allow us to be able to more easily make changes, sort of wider changes across our system, was that quite often, in order to get a change across the whole system, the team's priorities didn't necessarily align because maybe something that was most important for one team wasn't necessarily the most important thing for another team. But in order for everybody to move forward, we'd work on the basis that, look, it's possible for you to work in another team's domain, but with their guidance. So you can work with there, but share what you're doing, get feedback that is the team that's primarily responsible for this comfortable with the sort of change that we're looking to make. So the next thing then was appreciating the value of sharing. Because I mean, initially, to be honest, when we were getting teams together more to share more about what was going on, we were like, well, this is. In some ways, it feels a bit wasteful. You're like, well, should we really be getting all of our teams together and having everybody listening about things that maybe don't immediately impact them? But what we appreciated was that, well, actually, that's a price worth paying. It's a price worth paying because overall, although at an individual team level, it may feel not the most efficient thing, overall, actually, it did allow us to move faster. Then the next thing was having a temporary team with a cross-cutting aim. So another thing that we found, so we decomposed our team into a set of teams which had specific responsibilities in certain areas. And then we'd come across a problem. We've got no idea how to solve this. And we'd try, we know it's in this area, so we'd sort of say to a number of teams, we know this problem is in your area, and the way that your different services are interacting, can you try and figure out what's going on? And we found that was really slow. We found that actually teams getting together and quickly trying to find out, okay, well, which part of all of our systems in the way that they're interacting is the problem. It actually took quite a long time. So one of the things that we tried and actually proved to be quite successful was that allowed's not the right word, but we tried setting up a temporary team with one representative from each of the teams that we thought might be impacted. And their remit was basically to work together and try and figure out where the problem is. And actually, they found the problems much, much faster when we did that. So when we had a group of people together who were representatives from all the different areas that we thought might be at fault, when they were working together, they actually got to the bottom of the problem much quicker. Now, interestingly, those people working in that team, again, because we were starting to appreciate at this point the value of sharing, we said it was important that the people that were in that temporary team were regularly, every day, sharing back to their home team, if you like, what they were finding to get input, because that one person didn't have all the knowledge of that team that they'd come from. And so they were able to share what they were finding, and they were able to get input of other things to try. But the important thing here was temporary, because when we did this, and we're like, oh, okay, maybe having a team made up of representatives from all the other areas that's a really good thing. But we found that if we let it run on too long, 10 minutes, thank you, then actually it started to cause other problems, because we started to that team started then build things which weren't necessarily aligned with the way that each individual team felt it should be done. So it worked very well in terms of finding the problem, and then we were able to take that back to the home teams in order to figure out, okay, well, now that we know the problem, we can now figure out much more easily how to go about solving it. So in terms of keeping adaptability with stability, what we were trying to do, so we were, to be successful with what we were building, the problems are constantly changing. So the things that our customers need from our product is constantly changing. So we need to be constantly evolving to meet that. But also, we need some sort of stability. We need our teams to have things that they're that the people in the team, it's the same people in the team, and it's sort of clear what their responsibility is, despite the fact that the problems that we're needing to solve maybe are changing quite a bit. So how do we go about doing that? So what we were doing is we were aiming for a team always learning and always being challenged, but without imbalanced team performance. So we didn't want just one or two teams that were doing this really, really well, and actually then quite a lot of the other teams not doing it so well. We wanted to be adapting to meet new customer needs, but without leaving our existing systems unsupported. And then we wanted to make it easy to make cross-cutting changes, but without creating a new team being the very first thing that we tried. So the things that helped us on that. So the first thing was T-shaped teams. So I think I've certainly heard it referred to before in a team perspective as you want it's helpful to have T-shaped individuals in a team, people that have a depth of experience in one particular area, but a broad knowledge. That we found that actually that worked very well at the next level up, at a team level. So we wanted teams that had a depth of expertise in one particular area, but a broad knowledge to understand how the bits they were doing fitted into the bigger picture. Also, we found that we needed to constantly review the ownership. So once we'd got to a place where like, okay, it's now clear, we understand what each of our teams are responsible for, but because the problem was constantly evolving, we were finding, well, actually, we need to tweak this. Actually, the way that the ownership is currently set up is no longer right, because maybe 6 months down the line, the problems are actually quite different, and that we needed to change which teams were responsible for certain things. We found that it was quite important to share the new experimentation as well. So this is one of the places where having a sort of primary and secondary responsibilities helped, was that it gave us a few more options when there was a really interesting problem that we needed to solve, was try and make sure it wasn't always going to the same teams, so that everybody had a bit of a chance to try some new experimentation, and that certainly helped quite a lot. And then lastly, most effectively, I think, was actually getting some form of rotation between the teams as well. And that was almost certainly that was the best way for people to understand what other teams were responsible for. But the balance there was we wanted stability in the team, so we didn't want people to be rotating around all the time. But a sort of a low level of rotation between the teams we found was very effective in terms of people appreciating in more detail how their bit was fitting into the whole. So, in terms of then how do we measure? How do we measure that it was working, it was helping? Actually, the most important thing was literally talking to our teams and talking to them about how does it feel. It was we could have looked at metrics in terms of like how quickly are we burning down things, but actually, I think by far and away the most important measure was, do you feel like you are contributing the most at the moment? And what is holding you back from contributing? And actually, by talking to the teams and just understanding, that gave us the best feel about whether the sort of changes we were making were helping or not. So we were also asking, is it possible for our teams to work independently? So are there dependencies between teams, and is that a necessary dependency? We were asking, are our teams aware of what's going on around them? And then lastly, we were asking, are our teams happy? And basically, when we were talking to our teams, if they were happy, that was generally speaking a very, very good indication that we'd got things right. Because actually, if a team had lots of dependencies on another team, or if a team was making changes, but actually another team had made the same change, it resulted in an unhappy team. Because we've just wasted our time because we've done that, we've made that change in 2 places, we should have done it once. So that was, in all honesty, regularly talking to all of our teams and understanding how you're feeling, how's it working, was our best measure. And certainly as we did some of these things, so clearer responsibilities coupled with regular sharing, actually the feedback we were getting was getting more positive. And we were finding that then things were going out faster as well. But our best measure was by talking to the teams that are doing it day in, day out. So how does it feel? So in terms of principles and not prescriptions, so our context was unique. Certainly the problems that I've found in robotics were very different to the problems I'd seen before in teams that were working on maybe back-end cloud services, where we're releasing multiple times a day. The sort of problems that we had with coupling were very, very different to the different problems I'd come across before. So some of the ways that we set up ourselves up helped us with our specific challenge, but they also helped us with our specific team size. To be honest, if our team had been twice as big as it was, then half the things we were doing wouldn't have been appropriate. So it worked for us. I'm not saying it will work for you. But so I think the thing to look out for is look out for the warning signs as your teams evolve, and always be willing to change to get the balance right. So talk to the teams about how does it feel, and try and understand, and also be open to, do we need to change the responsibilities? Has the problem we're trying to solve changed, and therefore actually we haven't got the responsibility split quite right now? These were the wonderful books which helped us along the way. And to be honest, I mean, some of them we were doing it, and then we found the book. We're like, that's why it helps. And we didn't really understand why we were doing, why it was helping. And then we're like, oh, that's why. Anyway, 3 wonderful books that really help in quite different aspects. And then lastly, what we've learned. So the way that, what the biggest impact I think that we've seen, and it's actually the thing that we're still working on now, is that how our teams realize value, which ultimately is how they release changes to our customers, how frequently they're able to release changes and how that works, has by far and away the largest impact on how effective a team topology can be. Because if you have 20 teams, and if the way that they release changes is because all of those changes have to come together, and you have to do performance testing in lots and lots of homes, it drives quite a different problem space to teams that are able to release changes multiple times a day, completely decoupled. And actually, because they can release changes multiple times a day, if there's a problem, they can make a change quickly. So that's certainly the thing that we've appreciated, is that, and it's the thing that we're starting to look at more now, is, okay, right, given the sort of problems that we're facing, should we have different release strategies for different parts of our system as well? Because, and again, how does that impact the team responsibilities? And that is me. Thank you very much. Please do feedback, by the way. I'd absolutely love to hear any feedback you've got, anything that didn't make sense, or any problems that you've had that are similar. I'd love to hear about them. Thank you.
We have got a couple of minutes for questions as well, though, right?
Yeah.
Did you cap the lifespan of those temporary teams, or how did you manage?
We didn't initially. So initially we had a temporary team, which I think what we realised after was very much an enabling team in the team topologies model. We're like, okay, well, this is working, so we'll keep doing it. And then only once we started to see it causing friction, because we're like, actually, that team is now going too far, and the teams that those people have come from are starting to get a bit confused about the changes that are being made. And then we're like, oh, hang on, we've gone too far now. So once we'd learnt that, the way that we tended to work then was look for those warning signs and then say, okay, right, now's probably the time. We've probably learnt about the problem enough now that we can continue that investigation back in with people in their home teams. Sure, yeah.
Yeah, I'm interested in the idea of the teams of primary and secondary responsibilities. Can I just clarify? A team with secondary responsibility for a domain, was that a domain that had another team that had primary responsibility?
Sure. Okay. Yeah. So the question is clarifying what did I mean about primary and secondary responsibilities, and so in terms of it did mean that a team had a primary responsibility for a certain domain, and they would have a secondary responsibility that another team had a primary responsibility for. Yeah.
So,
sure.
Can I just ask
Of course. Yeah. Yeah.
Did that then feed into the kind of interaction between teams? You talked about teams working in other teams doing with guidance.
Yes.
So did that kind of take different forms, like maybe as simple as kind of like approving a PR through to kind of perhaps paving, or kind of like guiding a developer through making a change in the primary domain?
Yes, so the question, I guess, is elaborating more on what did primary response, secondary responsibility mean. So certainly what we did try to do, if a team was making a change in another team's area, then we would always look first of all to see, is it possible for the team that has a secondary responsibility in that area to be the team that's making the change, because they probably know a bit more about it. In terms of then how that worked in practice, sometimes, I mean, what we did try was maybe having one or two people from a team that really needed that change made, moving into the team that had responsibility for that, and working as part of that team. I mean, so they were there every day, they were talking about what they were doing, and they were getting feedback on the changes they were making. Yeah, so I'm not saying that we've got it perfect, but that's some of the things that we were trying. Yeah. Yes, yeah.
Who did you do them, in which intervals, and how many people were, or how many team members were involved in this rotation?
That's a good question. So in terms of how frequently we were doing the team rotation and how many people we rotate at any one time, we tried to not ever rotate more than one person into one team at any one time. Because we felt that if we did more than that, it was very, very disruptive for the team. So we were always trying to rotate just one person into another team. In terms of how frequently we were doing that for they would stay in another team for a period of maybe 10 weeks, 20 weeks, something like that. It was that sort of a number of sprints. That's it. Yeah, so certainly not one. Long enough for them to truly appreciate the way that team was working and the problems that they were facing. Okay. Yeah.
I guess you're talking about software teams, but there is also hardware. How does this relate to the hardware teams?
Ooh. Okay. Yes. So certainly I was talking about software teams. However, we have, in order certainly for a robot to work, there's an awful lot of interaction between teams that are responsible for the hardware electronics and the mechanical components as well. I guess what we found, I guess in some ways we did find similar things. So in terms of when we had a problem, we found it was most effective to get one or two people together that had experience of hardware electronics, mechanical and software together to try and figure out what that problem was. In terms of the sort of clear split of responsibilities, in some ways that was a bit easier because you were literally somebody who was primarily focused on building and designing electronic circuits. There was a clear separation in terms of that experience with somebody that was doing the mechanical components or the software. So it was more then how do we effectively bring those people together in order to solve the problem and find out where the problem is.
Brilliant. Thank you. That's all the questions we've got time for. Thanks so much, Andy.
Lovely. Thank you.